I would like to talk to you for a little bit today about is just a little summary of all linear systems. So what we're going to do is just draw a picture of the three cases that would happen with two lines, and then what happens in their equations, okay? So it's possible that when I have two lines, that those lines would intersect. And so if I had two lines and they intersect, okay, and all of the problems that I assigned you yesterday, you found an X and you found a Y. That would be this case. So this, we would say, has one solution. If you're thinking about things that are in slope-intercept form, they would definitely have to have different slopes in order to have one solution. How about the y-intercepts? They for sure have to have different slopes. Do the y-intercepts have to be different? No, because that could be the point where they meet. So I'm going to say that y-intercepts can be the same or different. It doesn't matter. Okay. Next thing we run across. We call this a parallel system, right? Parallel lines. How many solutions does something like this have? This has no solution. That's the one we came across in our opener today, okay? And when lines are parallel, this is a must. They have to have the same slope, and they have to have, if they have the same slope, they can't have the same y-intercept, because then that would be the same line, right? So they have to have a different y-intercept. Okay, and then last, when I draw this one, I usually use two colors, because if I'm trying to draw that I have a line, typically we don't draw another line on top of a line, but that's what's happening. I have two lines in there. If I graph them, they're the exact same line. Okay, we call these parallel, we call this coincident lines, or the same line, and this has infinite solutions. Okay. If something's infinite solutions and they're the same line, what would have to be true about their y-intercepts and slopes? Same. So we're not going to go through, I think you guys now, I'm not going to insult your knowledge of math, because it looks like from yesterday and today, you now remember what it looks like when you start to solve, and then you get a no solution or an infinite solution. But what I do want to tell you about is there is a case, and this actually shows up on the SAT a lot, and so every time that I find something in class, this is not a SAT class, okay? But if you're taking the SAT, we should talk about things that we're talking about that show up on the SAT. Sometimes what they do is they give you questions where they give you a system, and they ask you to figure out a number that would make it a no solution, and they ask you to figure out a number that would make it an infinite solution. So I'm going to just show you an example like that, okay? So I'm going to show you the one, we're going to write down the one that we did in our opener today, which was 8x, if I remember correctly, minus 8y equaled And then it was negative 16x plus 16y equals 20. Okay. So this is an example of no solution or parallel lines. Okay, so what I want to quick show you is, we're not going to go and solve it. I want to show you if they're the same line, that the ratios of all the coefficients and the ratio of what's on the other side is the same. And what I mean by that is this. If I would take this 8 and compare it to negative 16, that's the same as this negative 8 compared to this. Okay. Those are the same, aren't they? If you reduce them, wouldn't you get both negative 1/2? Okay, here's the big deal. In no solution, these ratios are the same. However, they are not ever going to be equal to the ratio of what's on the other side. Because otherwise, that's going to be our second case. Do you see how 18 divided by 20 is not 0.5? Okay. All right, good. So the other one that I want to show you is infinite solutions, but let's call this the same line. Okay. In a situation like this, let's see if I can give you one. You did one yesterday in your homework. I can finagle this one. 5x minus 2y equals 10. And then negative 15x plus 6y equals 30. Negative 30. Okay. We're not talking about solving, we're just talking about the characteristics of our two equations, okay? In this case, when it's they all have to be the same because they're the same line. So, if I would compare 15 over negative 15, by the way, you can think of it as a fraction, or you can say, hey, what would I multiply? This is times negative 3, right? Is it 15 times negative 3 or negative 15? Okay. That's equal to negative 2 over 6. Again, is it negative 2 times negative 3 give me a 6? Yep. But then it's also equal to this. Okay. And so that characteristic is what I'm going to tell you you want to use when figuring out that question. Do you want to do one? I shouldn't ask, do you want to? Because we're done. Let me show you one, and then the equations 3x minus 4y equals 5 and 12x minus 16y equals c, we don't know what c is, represent the same line. What is the value of c? Okay, so what I'm telling you is, if these are the same line, the ratio of all those things have to be the same. So the ratio of 3 to 12 has to be the same as the ratio of negative 4 to negative 16, which I hope you can see it is. And that's the ratio of 5 to c. Some of you can just do the multiplication in your head. Others, you might, if you want to, set up a proportion and cross multiply, okay? Any of them. What are these, what is this being multiplied by? 4. Sometimes it's a weird decimal, so then you might want to do a cross multiplication. So what's, if they're multiplied, all multiplied by 4, then what would C have to be? 20. So that's a very SAT-ish kind of question. You know what else is really SAT-ish? They like you to do things with your answers. Like, you see how I say what's x divided by y? They ask you to take your answer and do something with it. That's kind of what this first piece is all about. Right. So you guys have the rest of the time. You got 20 minutes. You're gonna ask me some really good questions.